Last time we have seen the definition of polarizer. Polarizer. It is a device which produces plain polarized light when unpolarized or ordinary light is incident on it. So this is unpolarized light. It is incident on the polarizer, and we get the plane polarizer. Now, how this takes place, how this conversion of unpolarized light to plane polarized takes place, that what you explain. So, polarizer is a optically active crystal. So we know this meaning of polarizer. Polarizer is an optically active crystal having optic axis, or it is also called as polarizing axis. Naturally or artificially synthesized. So we know the example, calcite crystal, quartz crystal, etc. So the crystal is cut in a particular section and it is shown like this. It has a hexagonal shape, like this, like a benzene ring, and it has a finite thickness. So these two points are called as a crowns of the crystal, and a line joining these two crowns is called as the optic or polarizing axis. So this is a optically active crystal. आपण मेकॅनिकल वेव्हच्या वेळेस रिएक्शन प्रोड्यूस करण्यासाठी आपण स्लिट यूज केली होती, रेक्टेंगुलर स्लिट. इथे आपण हा क्रिस्टल यूज करतो, त्याचा ऑप्टिक ॲक्सिस म्हणजे स्लिट कन्सिडर करायची. So by rotating this axis we can change the amplitude of the incident unpolarized light. How? So what to explain that use of polarizer to produce plane polarized light. Plane polarized light. So same figure we are using. Now, before explaining this use, let us consider the unpolarized light. Before going to this, we will see a representation and plane polarized light. Plane polarized light. So suppose these are y and z axis. So this is the y-z plane. The electric field vibration exists in this plane. So unpolarized, first we are going to consider this. So draw a circle. So this is one electric field vector. This is another field vector. This is a third electric field vector. This is a fourth. They are symmetrically distributed like this. So this electric vector is E1. This electric vector is the E2. This electric vector is the E3. Like this. So this is E1, this is E2, this is E3, and this one is E4. Like this. So these vectors are in this plane, in y-z plane, and the wave is traveling in x direction. So this is x-axis, this is y-axis, and this is z-axis. Y-axis, z-axis, x-axis like this. बरोबर. आता हे इलेक्ट्रिक फील्ड व्हायब्रेशन ह्या प्लेनमध्ये. आता E2 जर कन्सिडर केला तर आपल्याला E2 चे दोन कंपोनेंट करता येतील. So E2 is in this direction. So if you draw perpendicular, if this angle is the say theta 2, then this component is draw perpendicular. This component is the E2 cos of theta 2. And if we draw perpendicular on this side, then this is E2 sin of theta. So this E2 sin of theta 2 is in the direction of E4, and E1 cos of E2 cos of theta 2 is in the direction of E1. Similarly, you can consider E3. This is E3. So if this angle is theta 3, then draw perpendicular. So this is E3 cos of theta 3. Draw perpendicular. So this is E3 sin of theta 3. So in this way, if you resolve each and every electric field vector, then it has one component parallel to E1 and other component parallel to E4. So this component E4, it is along the z-axis like this. So it is a perpendicular to the plane of the figure. So E4, E2 sin of theta 2, E3 sin of theta 3 R. perpendicular to the plane of the paper, plane of the blackboard, and shown by dot, and shown by dot. While even E2 cos of theta 2, E3 cos of theta 3 are parallel to plane of paper shown by double headed arrow. Double headed arrow like this. Therefore, this is a very important rule. Unpolarized light, figure मध्ये unpolarized light आहे. Unpolarized light is represented by parallel component as well as perpendicular component, arrow and dot, and plane polarized light is represented by either it is represented by arrow only, no dot, or by dot only. So E vibrations are in the plane of paper and in this case E vibrations are perpendicular to the plane of paper. So this is a representation. Of unpolarized light and plane polarized light like this. So this is a very important point. जसं आपण सर्किट डायग्राममध्ये एमीटर, व्होल्टमीटर, रिओस्टॅट, सेलचे सिम्बॉल दाखवतो, तसे इथे पण आपल्याला सिम्बॉल दाखवायचे असतात. तर ते सिम्बॉल याप्रमाणे असणार ते. सो रिमेंबर दिस पॉईंट. सो ॲक्च्युली plane polarized light can be obtained by 4 or 5 methods. One is this method using polarizer. Second method is by using a reflection phenomena. Third is by using double refracting crystal, nickel prism. The fourth one is the dichroism, and one more method is the scattering method. So total there are 5 methods. Out of 5, 3 methods are included in our syllabus only. Remaining 2 are not included. So this is the first method that we are going to see. So the arrangement is like this. Suppose this is a optically active crystal. It is cut in a particular fashion. Just now I have said that these two are called as crowns. This is the thickness of the crystal. This is the optic axis passing to the crowns. This is the direction of light propagation. Light is traveling in the direction. This is the x-axis. So incident light is unpolarized light. Just now we have seen that it is shown by circle and dot. So this is the unpolarized light. This is the incident light which is unpolarized. Now you have to convert this light into the plane polarized light. So that plane polarized light is like this. Dot cut only. This is the plane polarized light. This is the aim of our article. But to produce the plane polarized light by using polarizer. This is the polarizer. This is the polarizing axis, or it is called as the optical axis. Optic axis. So, by passing the unpolarized light through a polarizer, this is polarizer, we can produce the plane polarized light. So, this is the method. Now, this transmitted light the incident unpolarized light has E vibrations in y-z plane perpendicular to direction of wave propagation. That is x-axis. This is x-axis. This is y-axis. And z-axis will be perpendicular. So this is the unpolarized light having vibration in all directions, symmetrically distributed. Now, what is about the transmitted light? Since light transmitted through polarizer has E vibration in only one direction, parallel to optic axis of the polarizer. Remaining vibrations are absorbed by the crystal. under the transmitted light is plane polarized light shown by arrow, double-headed arrow. If the crystal is rotated through 90 degrees, then it will be shown by dot. या इथे फक्त आपल्याला डॉट दाखवतो. तो either arrow or dot like this. हे आपण क्रिस्टल असा ठेवलेला आहे. This is the optic axis. So if the axis is vertical along y-axis, then the plane polarized light having E vibration like this. Now if the axis is turned through 90 degree, the again we get the plane polarized light, but the vibrations are like this and they are shown by dot. So either it is shown by arrow, double-headed arrow, or it is shown by dot. If the optic axis is along y-axis, along y direction, then electric field vibrations are like this. If the optic axis, this is the optic axis. If the optic axis is along the z direction, then electric field vibrations are also directed like this into the or out of the plane, and it is shown by dot. So either here we can show arrow or dot independent upon the optic axis. By rotating the optic axis, we can get the change in the direction of the plane polarized by E vibrations in the plane polarized light like this. So in this way we can get the plane polarized light. Now there are two types of plane used or defined. One is called as a plane of polarization and other is called as a plane of vibration. So first we will see what is the meaning of plane of vibration. Plane of vibration and plane of polarization. E. What is meant by plane of vibration? So the name itself suggests that this is the plane containing the electric field vibration of the plane polarized light. So the definition can be given: the plane in which the electric field vibrations of the plane polarized exist is called as the plane of vibration. So definition is very simple. Definition: it is a plane in which E vibrations, electric field vibrations of plane polarized light, vibrations are only in one direction, plane polarized light. It is a plane in which E vibrations of the plane polarized light exist. Is called plane of vibration. Plane of vibration. आता फिगर मध्ये आपल्याला प्लेन ऑफ व्हायब्रेशन ऍड करायचं आहे. तर प्लेन ऑफ व्हायब्रेशन असा असेल. So A, B, C, D. It is a plane in which the electric field vibration exists. Therefore, it is called as a plane of polarization. A, B, C, D is a plane of vibration. Plane of vibration in figure. So this is the plane of vibration. Now going to consider plane of polarization. What is meant by plane of polarization. Decapolarity plane of polarization मध्ये कोणत्या प्रकारचे इलेक्ट्रिक फील्ड व्हायब्रेशन नसतात. Plane of polarization. So it is a plane perpendicular to this. Means if we consider the arrangement like this, then if this is a ABCD, it is a plane of vibration. Then this will be the plane of polarization. They are perpendicular to each other. Electric field vibration exists. Electric field vibration never exists. So there are no electric field vibration. So definition is similar to this. The plane which is perpendicular to the plane of vibration and in which there are no vibration of electric field of the plane polarized is called as. So definition can be given like this. These two planes are always perpendicular to each other. The plane perpendicular to plane of vibration, in which there are no vibration of electric field of plane polarized light. प्लेन पोलराइज मध्ये ई व्हायब्रेशन असतात पण ते फक्त एकाच डायरेक्शन असते. जर या डायरेक्शन असेल तर हे प्लेन ऑफ व्हायब्रेशन झालं आणि हे प्लेन ऑफ पोलरायझेशन झालं. देर आर नो व्हायब्रेशन आयदर एरो ऑर डार्क. या डायरेक्शन व्हायब्रेशन असेल तर हा प्लेन ऑफ व्हायब्रेशन झाला, हा प्लेन ऑफ पोलरायझेशन झाला. So plane of vibration and plane of polarization, they are always perpendicular to each other. So now in this figure, if we are to show the plane of polarization, then it is perpendicular like this one. So I will show here. There it is. So P, Q, R, S. These two planes are perpendicular to each other. So in figure, PQRS is the plane of polarization. PQRS is the plane of polarization. ABCD, plane ABCD is perpendicular to plane PQRS. Like this. E vibration exists, there are no E vibration. So these are the properties. Now in both the plane there is a axis. Both the plane contains the direction of wave propagation. Both the plane of polarization as well as contains direction of wave propagation, x-axis, direction wave propagation. Then in our figure it is a x-axis. So it is a plane containing the direction of wave propagation and in which vibration exists, plane of vibration. No vibration of electric field exists, but it is the plane of polarization like this. So this is the meaning like this. So in this plane, this is the PQRS. It is a plane of polarization. This is a plane of vibration. This is a plane of polarization. Like this. So in this last article, use of polarizer to produce the plane polarized. So this is the method of production of plane polarized. Now this is plane polarized which is present in the transmitted light from the polarizer. So whether it is plane polarized or not, question mark. So we have to check, we have to detect whether this light is plane polarized or not. So in this figure we have shown production of plane polarized. Here we are using only one crystal called as a polarizer. Now we have to detect whether this light is plane polarized or not, and for that purpose we will require one more crystal. So याच्या पुढे येईल and it is called as the analyzer because it analyzes, it detects this vibration whether this transmitted light is plane polarized or not, and therefore for the detection of plane polarized light we have to use one more crystal here. So arrangement will be like this. This is unpolarized light. It is incident on the polarizer. Polarizer produces the plane polarized light. This plane polarized light is incident on the analyzer, and from analyzer we will get the electric field vibration. So by rotating this analyzer behaves like a second slit. आपण मेकॅनिकल वेव्हच्या वेळेस आपण 2 स्लिट एक्सपेरिमेंट बघितला होता. सो द फर्स्ट स्लिट इज polarizer and second slit is the analyzer. So in that case, by rotating the second slit S2, we can restrict, we can decrease, we can reduce the amplitude of the mechanical wave. Same role is of analyzer. S2 स्लिट S2 चा रोल आणि ॲनालायझरचा रोल सारखा, म्हणजे तिथे आपल्याला 2 क्रिस्टल यूज करावे लागतील, polarizer and then analyzer. So how the plane polarized is detected, that part we have to see. So this figure shows the production of plane polarized light. Figure 1 for production plane polarized light. Now we have to consider the detection of plane polarized light. Detection of plane polarized. So here we are using analyzer. The definition is similar to the polarizer. It is a device used to detect, to check, to analyze the plane polarized light. So here we are using polarizer and analyzer system. System are combination combination of polarizer and analyzer for detection of plane polarized. We are using the combination of polarizer and analyzer, and that arrangement is like this. So this is the as usual polarizer. These are the chromes. This is the optic axis. This is the thickness. P for polarizer. This is analyzer. Their axes are kept parallel. P for polarizer. A for analyzer. This is the common axis. This is x-axis as usual. So this is unpolarized light. So unpolarized light is shown by arrow and mark like this. This is the unpolarized light. This will be the plain polarized light. No dot. No dot. Plain polarized light. And now this plain polarized light is very incident on the analyzer crystal. So again we will get the plain polarized light. But the vibrations of plane polarized light depends upon the rotation of the axis of the analyzer. This is also plane polarized light because the two axes are parallel. Plane polarized light like this. So now to detect or to check whether the light from the polarizer is a plane polarized light or not, one more crystal analyzer is used. It is observed that light is transmitted to the analyzer and it is a plane polarized light when E vibrations are parallel to that from polarizer. The E vibration याच्या optic axis ला parallel पाहिजे. When E vibrations of plane polarized light from polarizer ray from polarizer are parallel to optic axis of analyzer. Then final transmitted light is also plane polarized light. But this point is important. But by rotating optic axis of analyzer, we can decrease the amplitude of E vibrations. Now, if this is the P, if this is the E, these are the axes and they are oriented at some angle theta. Theta is equal to angle between the optic axis of polarizer and analyzer. Then effect of theta on intensity or amplitude of finally transmitted light is the light dilated. So we are to see three cases. Case number 1, when theta is equal to 0, figure 1 is applied, that is two axes are parallel. Then the intensity of the transmitted light is maximum. Then intensity is maximum. Intensity I is maximum. Case number 2. When the two axes are perpendicular, when the two sheets are perpendicular, when theta is equal to 90 degree, that is two axes are perpendicular, then intensity I is the minimum equal to 0. And the third case is the trivial case. Case number 3. When 0 is less than theta, less than 90 degree, not 0, not 90. So in this case, then I decreases as theta increases from 0 to 90 degree. As theta increases from 0 to 90 degree. So when the two axes are parallel like this, the transmitted light has maximum intensity. When the two axes are perpendicular like this, the intensity becomes zero. Maximum intensity, minimum intensity, and intensity is between maximum and minimum as the angle increases from 0 to 90 degree. We are rotating only the second axis. Polarizer axis आपण turn करतोय. So when the axis of the analyzer is rotated from 0 degree to 90 degree, the intensity goes on decreasing. Maximum intensity goes on decreasing and it becomes 0 when the two axes are perpendicular. And the two set actions are the results are exactly like this. So in this case, when theta is equal to 90 degree, no light emerges. Polarized system मधून कुठल्या प्रकारचा लाईट बाहेर पडणार नाही. We can cut off the light 100%. So this is the important use of this system. So intensity control, intensity of the plane polarized light is controlled. Intensity control is the main use of this system, polarizer and analyzer. Intensity of the plane polarized is controlled from maximum to minimum by rotating polarizer. जेव्हा आपण पोलरायझेशन फेनोमेना ॲप्लिकेशन बघणार आहोत तो हा मेन पॉईंट आहे, इंटेन्सिटी कंट्रोल. Intensity of the plane polarized can be controlled by rotating the polarizer. So, by rotating the analyzer. So by rotating this analyzer, we can control the intensity maximum to 0. Maximum intensity when the axes are parallel as shown in the figure, and minimum when the two axes are perpendicular to each other. Like this. So intensity control, it is the main use, and it is used in so many cases like this. So what to see what is the intensity of the transmitted light in different cases. Okay, we will stop here. Okay, we will stop here.